Okay, today we're going to be learning about 3.11, factoring special cases. There are three types of special cases: perfect greatest common factor, perfect square, and difference of squares. Okay, first we're going to do greatest common factor. So, greatest common factor, first problem. Okay, our equation is 4x squared plus 6x. So first think about it that you can take, what can you take out of 4 and 6? You can take out of 2. Let's start with that. And so now you have 2 plus 3. Now they each have an x, so you can take out 1x from each one. Since it's squared, you take out 1, and you'll be left with 1. Because x squared times x squared is x. And then this one doesn't get anything. So that's our answer. Our next problem is number 2. Let's do something a little bit harder. Let's do 14x cubed plus 21x squared plus 28x. Sorry, that should be a minus 28. So what do all three of these have in common besides an x? So we all know they can take an x out for each one. What does 28, 21, and 14 have in common? Right, 7. So let's take out a 7 from all of it. 7. So that'll leave us with, you take out a 7 and you take out an x because they each have an x in common. So take out 7x. Okay, now this would be 2x squared. Because it's cubed, you're taking out 2. You're only taking out 1x, so you're left with 2x squared. Plus 3x minus 4. See? Easy enough. Let's do just something a little bit harder. Now, our problem is 12x to the 5th minus 18x cubed minus 3x squared. Don't let the large exponents trip you up because they're nothing too scary. Okay, so what can you take out of 12, 18, and 30? Okay, so if you have a small number like this, that usually means what you can take out of the equation. And if you take out that, it'll just be replaced by a 1. So let's take out a 3x squared from this and this. So it would be 3x squared. And remember, you're taking out a negative, so that makes your equation a negative. So you'd have 4x cubed, because you're taking a 2x out of that 5, minus 6x minus 1. Perfect square. So our first equation for perfect square is going to be x squared plus 12x plus 36. So For perfect square, it means that once you factor it out, you should get two same factors, which is what we should get. But since there's a 1 in front of the x, you can immediately just put down two set of parentheses and an x in each. And then what adds to give you 12 and multiplies to give you 36. That's right, 6. So, since we have two of the exact same equations, our equation is going to be x plus 6 squared. See, because if you multiply it back out, you should get this equation. Our next equation, second, is 81y squared plus 18y plus 1. Okay, just because there's a big number in front doesn't mean much. So, what gives you 81 times 1? Another easy way to do it, instead of drawing the little arrow, is an x. So, in the x, on top you write 81, and then on the bottom you write 18. So what multiplies to give me 81 and adds to give me 18? 9 and 9. So now you put two parentheses, and then you put a y in each, and then you do plus 9, and plus 9, plus 9. And so our answer is y plus 9 squared. Parentheses. They are very important. Third and final equation. So our third equation is 9x squared minus 24 plus 16. If the first, what gives me 9 times 16 and adds to give me 24? What multiplies to give me 144 and adds to give me 24? Sorry, that is a 4. Now our new equation is 9x squared minus 12x. Sorry, there shall be an x there. Minus 12x plus 16. Easier way to do it is to add up the first two terms and pull out the greatest common factor. When you add up 9 and 12, you get 21. So, what can we pull out of 21 that goes to both 9 and 12? Right, 3. And also we can take out an x since they both have an x. So take out a 3x from 9 and 12. So you have a 3x minus 4. And now we're going to do the same to 12x plus 16. What can you take out of That's right, you can take out a 4. So let's take out a 4. So our new equation is 3x minus 16. Oh, wait, no, not 16, 4. Brain fart. So now our new equation is 3x minus 4 and 3x minus 4, which is perfect because you want to get the same thing. If you get something different, then you trace your steps and do it again, see what you did wrong. Our new equation is 3x minus 4 squared. That is perfect squares. Okay, difference of squares. Our first equation for difference of squares will be 49x squared minus 1. This is simple. All you do is take out 7x. Since 49 is a perfect square, you can easily go straight into 2 parentheses. Since what's the square root of 49? It is 7. And so you put a 7x in each one, so when it multiplies back out, you get 49x. And then you get, since it's difference of squares, you're going to have 1 minus and 1 plus. So you're going to have a 7x plus 1 in one box and a 7x minus 1 in the other box. Any other parentheses. Hands not feeling it today. 7x minus 1. So if you multiply it back out, you should get 40. Our next equation will be 16x squared minus 49. So, since they're both perfect squares, you put 2 parentheses, you put the perfect square of 16x and 49. So the perfect square of 16x would be 4x. So we put a 4x in each. And then the perfect square of 49 would be 7. So and plus 7 in one, and then minus 7 in the other. For our third problem, we have 54x squared minus 6y squared. Okay, having 54x squared and 6x squared. Greatest common factor still applies, never goes away. So what's the greatest common factor of 54 and 6? Let's just take out a 6 since we have that number here. So we could take out a 6 and we're left with 9x squared minus y squared. Okay, now let's factor, keeping the 6 out. Keeping the x out still, we're going to have 6, and we're going to do the 2 parentheses since it's the difference of squares. Since 9 is a perfect square, we're going to put whatever the square root of 9 is into each of the parentheses. So the square root of 9 is 3, so we're going to put 3x in both. And then since we have y, it's just 1, so the square root of 1 is 1. So we're going to do minus y plus y. So then we're done. That's our answer. And that is difference of squares. So wrapped up greatest common factor, difference of squares, and perfect squares. Yay, we're all done.